Hello, everyone. I'm glad to present the blockchain-oriented software variant forks, a preliminary study. This work's being presented at the IWBOSE2022. I'm Henrique Rocha. I'm an assistant professor at the Loyola University, Maryland. And this is a collaboration work with my friend and collaborator, Dr. John Businge, who is a postdoc at the University of Antwerp. And this work has been sponsored by SequAssist. With the rising popularity of Bitcoin and Ethereum, we also have an increasing popularity of anything that works in the blockchain. Blockchain has become much more popular with regular users, but also has become much more popular in software. And now we have much more blockchain-oriented softwares for many different applications, like, for example, for dealing with supply chain or voting, crowdfunding authorization. There's many different applications of blockchain. And with the rising popularity of those softwares, you have much more development of those software. Those developments are done in social developing or the social coding platforms like GitHub, Bitbucket, and GitLab. And the advent of those social coding platforms also substantially improve the reuse of software and the collaboration of other people on software by forks. And that's very simple with fork repository to help promote reuse to it mostly. And we can categorize a fork into two main forks, basically. We have the social forks, where the main idea is that our fork a repository to do some work on it, maybe fix a bug or to develop a new feature. And then that fork later is pulled back into the mainline, so it's incorporated back to the mainline. And that's usually how we do the development, fork for development. That's the social fork. But there's another type of fork, what we call a variant fork. And in the variant fork, they're created to split the development into a new branch, in the way to still develop it into a new direction. The variant has no idea, has no purpose to join back to the main line. Its main idea is to develop in its own way, completely different from the main line, in a different direction. And we call a software family those sets of main lines with its variants. Of course, a variant may optionally give back a bug fixture that a bug fix back to the mainline, contribute back, or pull a bug fix that was done in the mainline back to itself. But that's not the main purpose of the variant. The variant, we always try to steer its development into a new direction. And here's just a few examples, motivating examples for this when we deal with blockchain-oriented software. We have, for example, here the Pix project, which is a software on GitHub. And you can see the Pix was forked from the -play repository. And the -play, and this is a wallet software, was also forked from Bitcoin. And it's a cryptocurrency -play was also forked from Bitcoin. And Bitcoin itself, we all know it's the main cryptocurrency that's the main repository that deals with the Bitcoin protocol, node, and cryptocurrency. So all those repositories together, we have the Bitcoin is the main line, and those two variants, they are the software family for this blockchain software here. And the idea for this was because once upon a time, Dr. Businge was mining GitHub repositories to try to see the motivations that lead to people to work on those repositories, to create those variants, and what made them create those variants, what are the reasons, and analyzing a bunch of different things on those repositories, on those variants. And John wrote a paper on this, which was presented 3 days ago on CERN on March 15. And when John was working on that paper, he was mining GitHub, and he came to me and asked for my help because he found some forks that were dealing with blockchain. And John knows a lot about variants. Dr. Businge knows a lot about variants, but he doesn't know much about blockchain. So he asked for my help to see, all right, why they're different. It was a wallet application, and he could not understand why they were different, why they were variants. And when I look over them, I realized that they were variants because they were implementing different blockchain platforms. One was a wallet for Bitcoin, and this other wallet was creating for another custom cryptocurrency, for different cryptocurrencies, to create a wallet for that. And John asked me why that happened. I started realizing, well, that makes sense because most of the time, if I want to support a different blockchain platform, it's much easier for me just to fork another blockchain software that I know it works well for one platform, and just change the protocol there to communicate with another platform. And I have the same software already, probably much more mature than for me to start developing one new. And then realize, whoa, that's interesting. So send me another blockchain software and the same thing happened. I said, well, that's interesting. Like how often does that happen? It's like, does that happen a lot in blockchain-oriented software? So we start analyzing those forks. So we use the same method that Dr. Businge used on his paper presented at Sunner and also on his previous paper on SME, on MSC. The main lines we gather using the GitHub REST API. We gather only popular, popular that has to have more than 5 stars and more than 5 forks. It has to be long-lived, created before 2018, so a long-lived. It has to have some activity on it. I think the activity has to be up to 2021. And for this study, we focus only on blockchain-oriented software. So it had to have blockchain, Ethereum, Bitcoin, cryptocurrency, some of keywords that related to blockchain for us to analyze those. And what we deem as a variant from those mainlines has a lot of forks. So which forks we consider a variant are those that has to be at least 3 commits ahead the mainline. They have to have more than 3 stars than the mainline. It means that they're evolving differently. And they have to have diverging README files. So the mainline has to have some divergence there. In total, we found 124 mainline softwares and 237 variant forks. From those, we're analyzing those, 91 of those mainlines only had one variant. That's 72% of our data set. The median value of, that makes the median value of the mainlines has one variant. That's the median value for the variants on our mainlines. It's one variant, the median value. On average, the mainlines have 1.91 variants in our data set. And this is the top 10 mainline blockchain-oriented software applications that we have in our data set. Together, they have more than 86 variants attached to those blockchain softwares. We manually analyze each one of those 86 variants. So we read them all to see why they would diverge, what's the reason, or why they diverge from the main line. So what's the reason for those variants to exist? I'm not going to show all here during the presentation. I'm going to focus on a few examples that I thought was interesting. In the paper, we analyze all 86 of them, and you can read the paper to see the data that we found on all 86. We did not analyze all 124 because of lack of time, but or 237 variants due to lack of time. But we do plan to do that if we find, especially if we find a student to help us continue with this research. The top one repository mainline in our data set is the Go Ethereum. That's the official implementation written in Go of the Ethereum protocol, and that's also the client node for Ethereum. And you can see here, that's the official implementation. That's a screenshot from their repository. And those are the variants that we found for that Ethereum. Those are the 19 variants that we found. Over those 19 variants, 8 of those was only to support a different platform. So they forked that Ethereum implementation to create another cryptocurrency or another blockchain platform based on Ethereum. It's possible that some of those could be also side chains to Ethereum, but we didn't investigate that far. We have also 2 repositories there, 2 variants, which based on our analysis, the reason for its creation was to improve the performance or the efficiency of the algorithm. Other 2 was to improve the protocol. There was also some 3 that was based on 3 or 4 that was based on technological improvements. And 4 of them were unspecified. We could not find the reason why they are variants. We flagged as a variance because there was different in the, because they had commits ahead. So based on our analysis, we flagged them as variants, but we could not determine the reason for why they exist or what makes them so different from the main line. Here's an example of one of the Ethereum variants. That's the xfin.org chain. So this is to support a different blockchain platform. It was forked from Ethereum. You can see that fork from Ethereum, go Ethereum. And this is like supposed to be implementing the xfin network or the xfin blockchain platform, which is the reason to support a different blockchain platform. They just fork Ethereum and create their own. Another variant, this was from the ISWAT support, is to support a different type of technology. You can see here the README file says that's supposed to be to add the IWBOSE support to the Ethereum virtual machine. And if I click that on the link to the testnet of ISWAM, the README there said that this is supposed to be the primary candidate to replace the Ethereum virtual machine for the Ethereum 2.0 Serenity roadmap. So you see there's a different technology. That's why it diverted from the original Ethereum mainline. Monero is a cryptocurrency. That's the top 5 on our list. That's Monero. It's a cryptocurrency, supposed to be secure, private, and traceable. It has 9 variants according to our analysis. And in those variants, 8 out of 9 of them was just to support a different blockchain platform, to create a different cryptocurrency in a different blockchain platform. We found a similar thing on Bitcoin. And look at the variants that we found for Bitcoin. The Bitcoin has 12 variants, and out of those 12, 10 are just to support a different blockchain platform or to create a different cryptocurrency. And we can see here the Monero variant. It has that's one of the variants from Monero. It's created, the auction was created to support a different cryptocurrency and a different wallet for it. And as final remarks, this is a short paper. We found out, we manually analyzed 86 variants from our top 10 mainlines. And we found out that the most popular reason to create a variant is to support a different blockchain platform. That happens 65% of the times. And if you think about it, it makes sense. As I said before in the beginning, if I plan, for example, to create a wallet application for my own cryptocurrency, instead of me creating everything from scratch, I could just find another wallet that I know that works well for a different blockchain platform, fork it, and just change the protocol here to my blockchain platform. If I want to create my own blockchain, instead of creating the whole thing from zero, from scratch, I can just fork Bitcoin or fork Ethereum, depending on which of those I think gives me more support to the things that I want for my new platform. So it makes very sense. We know that makes sense, but we don't know how often or how common this practice was before. And apparently it's really, really common on blockchain if I want to support something from a blockchain, instead of creating from scratch, I just found a similar blockchain-oriented application that exists, fork it, change the protocol, and then I have a whole new support, a whole new software support in different blockchain platform. Another common reason that we found was to extend the mainline with additional features. And we have no idea why these extensions were not integrated into the original repositories. Maybe divergency with the mainline repositories. Maybe they didn't thought was good enough to integrate to the mainline, or maybe they just, well, didn't have the reason or option to integrate with the mainline, and they want to keep their development separate. 14 of those repositories, we cannot find any reason for it. Unfortunately, we read the readmes, we read the help, we even look a little bit at the code, but we cannot find the reason why they forked. So this could be an issue with our data collection. Maybe those were not really variants, although they are ahead of the commits, so someone is contributing to them, but not putting back into the main repository, which is strange. So we flag them as variants, but we have no reason why they exist. For future work, we plan to analyze other aspects of this variants like the number of commits or the number of stars or social metrics. I also want to look at the technical debt and many other metrics. We also plan to investigate the other variants from this data set. We only investigated 86. We want to look at them all, but we need more time for it. We also think it would be interesting to contrast with the non-blockchain repositories, non-blockchain variants, to see if the reasons are really that different. Like we know that for blockchains are very common to fork, to create a variant to support a different platform, but I don't think that would be common for other domains. So if you contrast with non-blockchain, would those be different? I think it is, but that's something that we want to investigate. So thank you very much. I hope you enjoyed this presentation. There's my email and John's email. Please contact us if you have any questions or if you want to discuss collaborations. We are open to it. And we are also glad to answer any questions, to send you the paper if you want to. And we can even talk about the data sets publicly available. We can send it to you as well. So please let me know if you need anything. Thank you very much, and I hope you enjoyed the presentation.